Welcome everyone. In this lecture I am going to introduce you to some of the instruments for measuring the weather data. I am sure in future you are going to use at least some of them, or at least you are going to use weather data collected by these instruments. So it is always good to know about these instruments and the principle of their working, so that you have a very deep knowledge about the weather data, how they are collected and how they should be presented and how they should be used for your future projects as well as other research work. First, I am going to tell you about thermometers. I am sure all of you might have used a thermometer at least for checking whether you have got fever or not, and that is called the clinical thermometer. It is very specially made because there is a constriction for the mercury column, by which mercury will not fall down when you take it out from your mouth to record your body temperature. Okay, I am not going to tell much about the clinical thermometer. I am going to tell you about the ordinary thermometer, which is used for making measurements of the atmospheric temperature. The first one is the simple mercury bulb thermometer. Sometimes you will find it is not mercury that is used. For example, in this particular picture you see a red liquid. There are a number of liquids that are used instead of mercury, which are very common in thermometers of today. Anyway, the glass thermometer that is being used now, it is marked, we use the Celsius or you call it the centigrade, and there is a bulb for the thermometer and there is a column by which the liquid in the bulb is going to rise as the temperature is increasing. But one of the things that you should remember with this thermometer is that as soon as it is recording actually the atmospheric temperature. So you may be observing a temperature at one place, and when you move the thermometer to another location, you may be recording another temperature, and you don't have to jerk like the clinical thermometer. It will be recording whatever is the temperature of the ambient air. So the most important thing that you have to observe while using the thermometer is that you should keep the reading, the label on the thermometer parallel, parallel to your eye. So you should be looking at it straight into the reading of the thermometer, and then you get a correct recording. And another one that you can see to the left hand side is the analog thermometer, which is fixed on a board, and it is recording both Fahrenheit and Celsius temperature. It is almost the same as the other one, but just fixed so that you can fix it on a wall and then regularly record your atmospheric temperature at a suitable location. And then you see another square or a rectangular device, which is actually a digital thermometer. It is actually recording both Fahrenheit and Celsius, and also it is recording the time. So in a digital thermometer you can directly read it. Now you may ask the question whether you can depend on digital thermometer. To some extent we can depend, depending upon the manufacturer. It varies, the prices vary, and if you buy a good digital thermometer, it is mostly sufficient for your routine work. But always remember that in a weather station which is being reported to the India Meteorological Department, this kind of a device is not accepted by them. So, but for your personal use or your project use, you can always use a digital thermometer. Okay, we hang on to the thermometer. In this particular slide, what you see is a device which is installed in the field, and you can see that there is a box with all the four sides of the box fixed with levers. Now, what exactly is this? This is actually called a Stephenson screen for enclosing thermometers especially. Now, what is the advantage of this Stephenson screen? When you measure the atmospheric temperature, it is very important to take very important precautions. The first one is that no direct sunlight should fall on the bulb of the thermometer. The second one is that there should be a free flow of air at the place where the bulb of the thermometer is fixed. Okay, now what is Stephenson screen? Yes, Stephenson screen will not allow the light to fall directly on the bulb of the thermometer, as the roof is actually two-layered with a wooden roof, so there is no question of the water or rain also falling onto the thermometer. And at the same time, the levers at the sides of this box will allow free flow of air inside this box even when it is closed. So this is the open position when we are going to take the reading, and also to show you how the thermometers are fixed inside this particular box. Nowadays you see that you have a lot of electronic thermometers, and you will not find such a detailed Stephenson screen or box of the olden type in the modern instruments. You will see a much more compressed Stephenson screen, and inside that you have the electronic thermometers, or we also sometimes call them thermistors, and they are enclosed there, but the principle is just like that of a ordinary Stephenson screen, that is preventing the bulb or the instrument or the device of the thermometer so that it does not get any sunlight directly, and also there is a free flow of air inside where the thermometer is kept. Now, there are many instances where you would like to leave a thermometer going on recording even in your absence for several days or several weeks or even several months. So the solution you can find in Hydrothermograph. This is another instrument where you can see that a graph is actually fixed on a drum which rotates with the help of a timer, and you can see two pens recording on the graph automatically while the drum is rotating and the graph is rotating along with this. One of them is recording temperature and the other one is recording relative humidity. So both the things are there, and that is why it is called Hydrothermograph. Hydro actually refers to humidity and thermo refers to temperature. So you will finally you can have different types of graph papers fixed on it, and you can get a regular recording of the temperature and humidity data for whatever period you would like to have after leaving it in the field in a proper enclosure, in a Stephenson screen preferably, and that is the way to collect a continuous recording of the data throughout the day and throughout the night. Okay. Now let us come to measurement of the relative humidity. For measuring relative humidity, again you can use a thermometer. For example, in this particular figure, the first figure actually shows two thermometers fixed on a board, same type of thermometer. One is called the dry bulb and the other one is called the wet bulb. but the wet bulb is actually below the wet bulb thermometer. With the help of a wick, the bulb of the thermometer is covered, and that wick is actually going into a reservoir of water. And you look at the temperature after a few minutes, and you can see that the wet bulb is actually recording a temperature a bit lower than the dry bulb thermometer. So you notice the difference between the two. That is the dry bulb temperature and the wet bulb temperature, and the difference between the two thermometers. Now, looking at a chart, you can easily determine what is the relative humidity of the atmosphere at that time. This is a very accurate method, and it is called the wet and dry bulb method of measuring the relative humidity. So the instrument really looks like the one that is in the center, that is called the wet and dry bulb setup, with a reservoir of water beneath that, and you can hang it on a wall and then have a record of the relative humidity at whatever intervals you would like to have. At the same time, in some people would like to use a dial type hygrometer for knowing the relative humidity. Actually, there is a hair type mechanism inside this hygrometer, which is actually responsive to the change in the relative humidity of the atmosphere. So actually that is connected to a lever which moves across a dial, and it records the relative humidity. In fact, these dial type ones are quite convenient, but at the same time they need not be very accurate as the one which is used, that's the one that is the value given by the thermometers. But there are places where it is very much used. For example, in a glass house or a greenhouse, they use this dial type one because they would like to plan the irrigation and all that. So they would like to have a quick reading of the relative humidity of the atmosphere in the greenhouse, and then they may like to open the tap for watering and all that. So that for such purposes this dial type 1 is sufficient. Okay, I would like to introduce you to a very accurate and field method of measuring relative humidity instantly, and this is with the help of an instrument called the Sling Cyclometer. Now, what is a Sling Cyclometer? Actually, you have two thermometers here, one with a wick fitted on it, and the other one is the dry bulb. So it has got a wet bulb and a dry bulb. So what you do is that you wet the wick with the help of water, and with the handle, the wooden handle that you see on this instrument, you hold it tightly, and then you can rotate this thermometer, both the thermometers, very fast in the atmosphere where you want to make the measurement. After rotating for a certain period of time, maybe a minute or a couple of minutes, then you take the reading of the wet bulb as well as the dry bulb and find out the difference, and look into the same chart where you can easily determine what is the relative humidity of the atmosphere. This is a very accurate method, and it's a very instant method for in the field that can be which we can use for knowing the humidity of the atmosphere. Okay, let us come to the measurement of rainfall. Rainfall is usually measured with the help of the instrument called rain gauge. The rain gauge that you see on the left hand of this slide is the usual one that is used in a weather station. But nowadays you will find many modifications of this one, which are made of glass as well as acrylic, and which can be kept on a stand in the field. So the important thing that you see in this rain gauge is an open funnel at the top, which is actually leading to a measuring cylinder, which is kept in another acrylic case. So as the rain is falling, the rain is caught by the funnel, and then the measuring cylinder is filling up. and this measuring cylinder is not the usual one, but it is actually marked in millimeters and not milliliters as the usual measuring cylinder, so that you can easily know how much rain it fell for a particular period of time, say for 24 hours, last 24 hours what was the rainfall, and this can be read by taking out the funnel from this device, and taking out the funnel as well as the jar from this one, and then directly reading the amount of rainfall. Okay, we again go into the structure of a rain gauge. As I have told you that you have got a funnel at the top, and which will be leading to a glass bottle also instead of a measuring cylinder, and this glass bottle can be emptied into a measuring cylinder, and you can make a measurement of how many millimeters or how many liters of water has collected. These liters of water will then have to be converted into millimeters. So you have got the second figure of an ordinary measuring cylinder, and then you have got another one measuring cylinder which is marked in millimeters. So that kind of a measuring cylinder is most suitable and usually supplied with the rain gauge, so that you can make a direct measurement of the rainfall. Otherwise, if you use an ordinary measuring cylinder, you will always have to convert it, and that I will show you in another class. So, and you should also know that for each country, the diameter of the mouth of the funnel or the area of the mouth of the funnel is also very important. For example, in India we use 200 square centimeter for the mouth of the funnel, whereas in UK they use 450 square centimeter for the mouth of the funnel. That is a much larger funnel than what we use. So the rain gauges will need to be calibrated by the India Meteorological Department if you want to really present that data for the public. Okay. In a manual rain gauge which I have shown you in the previous slide, you have to go every day and then make a measurement of the rainfall by emptying that water and then measuring it using a measuring cylinder. But in forestry and wildlife studies, you may not be able to go to some remote areas every day and make a measurement of the rainfall. So there is a solution to that, and that can be done with the help of an instrument called the tipping bucket rain gauge, which is an electronic rain gauge which can measure and store rainfall data at programmed intervals. So simply, as you see in the first figure, if you open this particular instrument, you will see that there are two buckets which will be tipping over based on the gravity. When the mouth, this also has a funnel at the top, and it is collecting water, and the water, instead of going to a vessel, it goes to one of these tipping bucket which is in position. When that bucket fills, it tips over and empties that water to the outside, and the other bucket comes in position. Now there is a reed switch which is fixed on to this bucket, which will be electronically recording this tipping of the buckets as and when it is done. So this is actually added up, and each tipping of the bucket is actually calibrated as 1 millimeter or half a millimeter depending upon the manufacturer of this rain gauge, and this is then conveyed to a data logger which is actually hidden inside this one. So you can go, say, after a month or two or something like that, depending upon the capacity or the memory of the data logger, and then take out the data logger, connect it to a laptop computer, and then download the data. So you know for a particular period what was the rainfall and that too even you can program it in such a way that you may like to know every hour what was the rainfall, or every half an hour or every minute what was the rainfall. So that will be very useful sometimes, especially when you are studying the movement of the animals or the behavior of the animals, and also something related to with the plants also. Coming to measurement of the wind. What you see in the figure is a wind sock, which I am sure many of you would have seen while going to an airport. Actually, windsock is nothing but a ring, a metallic ring, to which is fixed a sleeve of a cloth sleeve with different colors at definite intervals. Now, what exactly is the windsock meant for? It is actually meant for measuring both wind velocity as well as the direction. Maybe it is better to call it wind speed rather than velocity. So what it does? Actually, when the wind is blowing, it is actually caught inside this ring and it goes through the sleeve of the cloth. And then it is actually turning into different directions depending upon the wind direction. So you know what is actually the wind direction, as up on the pole to which it is fixed, you will see also a north, south and east, west direction indicator. And at the same time, how many of these rings of cloth is actually being blown by the wind indicates the velocity. For example, you can see in this particular figure, that is the second figure, it is not actually the whole sleeve is not very straight. That means that the wind is actually blowing at a very low speed. So if it is blowing at a particular speed, only a part of the sleeve will be actually straight, the other part will be almost in a wrinkled position. So this is actually a simple way of knowing what exactly is the speed and direction. In fact, it is a very old instrument in the sense that this was actually probably used for aeroplane pilots, so that from the sky they could know what is the wind velocity and what is the wind direction before they could land on a particular area. And at that time, you know, there was no radar communication as you have here nowadays here in most of our airports today. Okay, this is a very modern wind vane which actually gives the wind direction, and an anemometer which is actually measuring the wind velocity. The wind vane is actually fixed on the pole, and as the wind direction changes, it is actually fixed. I mean, the whole thing actually rotates on this center of the pole, and then this is actually calibrated against the degrees, that is from 0 to 360 degrees, and this is actually conveyed to a data logger. So we know instantly what exactly is the degree, and from which we can read in which direction the wind is blowing. And second is the anemometer, which is actually measuring the wind velocity. Here again you can see it is actually a cup counter anemometer which has got a reed switch inside. So as the cups are rotating by the speed of the wind, the reed switch is actually counting. So the number of counts per second or per minute will indicate the velocity of the wind. So both the direction as well as the velocity are measured using this particular equipment. In some of the researches, it is important to know the sunlight duration, because there are many animals which will be moving around only at certain period of the day or night. So you would like to know what was the duration of the sunlight for a particular day, because it is always changing, you know. Now for that we generally use something called the Campbell-Stokes sunshine recorder. As you notice, it has got a very prominent glass sphere which is actually acting like a lens and catching the sunlight coming from all directions. And it is actually led to a paper which is calibrated and fixed below the sphere. As you can see from the second figure, the green paper which is marked with the plus signs, and each line is actually 1 hour. So this sphere which is acting like a lens is actually catching the sunlight, and it will burn this paper very uniformly, very in a very small, a narrow line, so that after taking out the paper, you can count for a particular period of time how many hours the sunlight was bright and how many hours the sunlight was very faint, and for how many hours there was no sunlight. So this is actually Campbell-Stokes sunshine recorder, which of course is not very much used in weather stations nowadays, because there are many electronic instruments which are used instead of that. As I told you in the last slide, the duration of sunlight nowadays we don't measure very much. We measure actually the quantity of the sunlight at different intervals of time. For that we use radiometer sensors. You find a large number of radiometers nowadays, because people are interested in different wavelengths of light. So the visible spectrum and the invisible part of the spectrum and the infrared part of the spectrum, people are interested in different types of information. So you have different types of radiometers for making measurements of the different period of the spectrum. For example, the figure on the upper part shows a quantum sensor. A quantum sensor is nothing but which is measuring the visible part of the spectrum. So that is also important for photosynthesis. So if somebody who is making measurements of photosynthesis, this kind of a radiometer is important. And you can see below a rod-shaped radiometer which has got a number of radiometers mounted inside. You can't see each of them, but this is actually meant for making measurements below the canopy in a forest. For example, the sunlight is coming through the canopy, and it will be there are bright parts and dark parts while the light is coming through a canopy, because of the leaves are distributed differently. You would like to know how much light is actually, and then the cumulative light is coming at the bottom of a forest. So you will need to use such a type of radiometer, which is actually called a line quantum sensor. So what you should know is that there are radiometers for measuring UV radiation, infrared radiation, visible part of the spectrum. Then there are of course radiometers which will measure the total solar radiation also. So depending upon your requirement, you have to buy that kind of a radiometer. Another instrument that is generally used in weather stations is the barometer. Barometers indicate the atmospheric pressure, and this is especially important when you are into forecasting the weather of a particular place. So the barometer will indicate the air pressure, and then you will be able to say whether the clouds are going to come, or in a particular number of hours the rain is going to come. Many of these things, the barometer is important. Usually the mercury barometer is there, but at the same time nowadays more conveniently the dial type of barometer is there, which is actually making measurements based on some sensors that are inside. Anyway, this is not a very important thing, especially in forestry work that we are doing. So I am not going into the details of that. You may be able to read. If somebody is interested, you can read. There are many publications on barometers. Okay, in today's digital world, the entire weather measurement has gone into the digital way. For example, we have got the automated weather stations, where you find there are all kinds of equipments fixed onto it which can measure different parameters of the air, like air temperature, relative humidity, rainfall, solar radiation, and wind velocity, wind direction, soil temperature. All these things can be measured with the same instrument. So this is called the AWS, or the automated weather station, and the added advantage is that it is having a solar panel, so that the battery which is used for working all these instruments will be charged by the solar panel. At the same time, if you have installed such a weather station in a location, so for example if it is a remote location, you can have the data collected from it with the help of the satellite technology on your mobile phone. Sitting in your laboratory or in your office, you can collect the entire data. So this is now very common practice to have automated weather stations at different locations. But I tell you, even if it is automated, you have to give some attention to the maintenance of the instruments. Otherwise, there could be some failure of the weather data. If you are looking for continuous weather data, sometimes one of the instruments is not working. There is always a break in the weather data. So you have to be careful that this is maintained in proper condition, so that you have a very regular data collected in your mobile phone or on your computer. Okay, with this we finish this class, and I am sure you have got a very good understanding of the different instruments that are used in weather data measurements. Maybe you are going to use some of them in future, or maybe you are going to collect data which are generated by these instruments, so you know what you are doing. I will give you some bit of training in another class with regard to making your own weather data measurement, so that even using very simple equipments you can do weather data measurements in the field, especially when you are doing your projects in the forest. How to measure temperature, how to measure rainfall, how to measure relative humidity, etc. Thank you.